Now, polyatomic ions. Now, polyatomic ions are what the name says. More than one atom, charged particle. Okay? Poly, more than one. Atomic, meaning an atomic particle. More than one atom with an ionic or an ion charge or a charge on it to make it an ion. Now, what this means then is, further what a polyatomic ion is, it's kind of like a molecule with a charge. Remember, a molecule is covalently bonded. So is a polyatomic ion. Okay? Like an ion, okay, if it has a positive charge, the overall covalently bonded structure has more protons than electrons. If it's a negative ion, the overall covalently bonded structure has more electrons than protons. Okay? So let's look at a couple of examples here. Okay, so this is the sulfate ion. Now, the sulfur atom has 16 protons and electrons. The oxygen atom has 8 protons and electrons. Since we have 4 oxygen atoms, in sulfate, we should have, yes, 16 protons and electrons. I'm going to make it an X. Is that okay with you guys? Because we're talking about now X is going to be both the protons and electrons. In sulfate. Since we have 4 oxygen atoms in sulfate, we should have 16 protons and electrons plus 8 times 4, or 4 times 8 protons and electrons. Yes, X is going to be all the protons and electrons here, okay? You had a calculator, get it out in practice. Okay. What? Eight protons and electrons, and there are four of them in sulfate. What do you mean, is that like a formula? All we did was to look at the total number here. There's one sulfur with 16 protons and electrons. That's what this is. There's four oxygens. Each oxygen has 8 protons and electrons. And so we're looking at 4 times 8 because there's 4 oxygens in sulfate. So 16 protons and electrons for the sulfur, 4 times 8 protons and electrons for all 4 oxygens. Does that not make sense? So how many protons and electrons should we have? How many protons and electrons should we have?
48.
Okay. That's 48 protons and electrons in one sulfur. Oops, I don't need an E on the end. And 4 oxygen atoms. That's what we get when we combine one sulfur and 4 oxygen atoms. However, the sulfate has a 2 negative charge. Since the sulfate has a 2 negative charge, what's going to give it a 2 negative charge? What's going to give it a 2 negative charge? How did we get a 2 negative charge when we made monoatomic ions? Really? Huh? Has to gain something. What does it have to gain? Electrons. Must have 2 extra electrons. So, the sulfate ion, SO4, 2 negative, has how many protons? Look at what we wrote and answer my question, please. How many total protons does the sulfate ion have? If I have 1 sulfur and 4 oxygens, 48 protons.
What is that little, is that a 4 and what is the next?
It has 48 protons. Because the sulfur has 16 protons, and oxygen has 8 protons. I have 4 oxygens, and the answer is 16 plus 4 times 8 gives you 48. That's where we got the 48 protons. How many electrons must we have then? Not if we have a 2 negative charge. 50. That's where the negative charge comes from. Remember, monoatomic ions, if they're positive, have more protons than electrons. If they're negative, they have more electrons than protons. The same is true for this entire structure when you add everything up. This structure's got to have more electrons than protons in order to be negative. In order to be 2 negative, it's got to have 2 more electrons than protons. Does that make sense? Okay? So, the nice thing about polyatomic ions is that you simply name them from the chart in your references. Most names with an 8 or ite ending will be polyatomic ions. Most formulas with more than 2 elements, in this class anyway, most formulas with more than 2 elements will include a polyatomic ion. Now somebody might be watching this video who's in college and they'll say, wait a minute, that's not true. This is a high school college prep chemistry class, and for a college prep chemistry class in high school, this is true. You understand? Because if you take chemistry in college, you may find a lot of exceptions to some of these guidelines I give you. Got it? Okay. All right. Now, elements, more than 2 elements. Most formulas with more than 2 elements will include a polyatomic ion. Okay? Yes, you may. Okay, now you try it. Look it up. What's the name of this thing? Oh, sorry. What's the name of that thing right there?
There's oxygen, right?
Yes. What?
Phosphorus and oxygen.
What's it called? Phosphite. Okay, it's right in your test references. You just got to find the formula and write the name. Okay? Don't make it hard. Let's try this one. What's the name of this?
Nitrite.
Nope.
Nitrate.
It is nitrate. That's when you want to, when all else fails, like read the instructions. When all else fails, actually look it up. Nitrate. How about this one? What's this one called? Chlorine and oxygen. What's it called? Nope. When all else fails, look it up. Perchlorate. Well, he's actually doing what he should be doing. He's looking it up.
Is it from this?
Yeah, that's it.
Where? I was looking for the picture. Was it common ion?
There you go. Common ions.
Somebody got
There you are.
trying to be green.
Okay, so what is the formula for, what's the formula for this? Just look it up.